Hello again, young people. It's video number 3 from Unit 2.4, and we talked about carbon cycle in the last video and a couple of ways in which carbon moves between the spheres and the net gain in the atmosphere of 5 billion tons of carbon per year. This video we're going to talk a little bit about models, which we've talked about before, but I'm sorry if you can hear my dog snoring in the background here. It is what it is. So we have scientists use models to explain and understand big systems. The simplest form of a model, it's called a black box model, black box. It only shows 3 things, and it's where scientists start. And it's where the likes of you and I should also start when we are modeling any kind of system, trying to understand it. And a black box model is simple. There's only 3 things that we are concerned with. We want to know the boundaries of the model. So in other words, what's in the model and what's out of the model. And we want to know about our inputs. We want to know about our outputs. So a black box model, we've got some system. We define what is the system, and then we look at what goes in and what comes out. Easy as that. The boundaries of our model define what are called reservoirs. Usually when we say reservoir, we mean a big tank full of water, or maybe a big underground pocket of water that we can drill down to get water. But reservoirs are simply they're anything that can contain something else. And in our simple black box model, our reservoirs are defined by the boundaries of the model. And then our inputs and our outputs, those are just the processes that can cross that boundary. So, maybe a good model would be a good example. How about a car? We could say a car is a simple model. If we made a black box model of a car, everything that makes up that car would be in the model, but we wouldn't be concerned with that. All we'd be concerned about would be the inputs and the outputs. So what do we input into a car? We input gasoline fuel, crosses the boundary. Turn on the key, an internal combustion engine fires up and pistons and valves move and open and close and stuff. But we're not interested in that. That's all inside the boundaries of our model. What comes out the other side of the model would be kinetic energy, and that would be the car moving, and maybe the exhaust coming out of the tailpipe. That would be another part of our black box model. For a car, simplest thing I could come up with on the fly. So different models use different scales. For example, I could model the photosynthesis of a single tree, or I could model the photosynthesis of an entire forest. And if I'm looking at a big scale like the entire forest, I'm not interested in what's going on with the single tree. I'm looking at the whole forest, right? So when we have different scales, we're going to have different boundaries. But the last thing I want to... Oh, no, never mind. There's a couple more things. So when we're dealing with models, an important thing when we're making a model is to decide on some initial conditions. A model usually helps us see how something changes, how a system changes, but we need to decide how it starts before we can know how it changes. So that's what our initial conditions are. And scientists who work with models, they start with a simple black box model and they start changing little things and making the model better and more suited to what they're trying to learn. So that's our black box model. A full model now, not a black box model, but a full model, does everything a black box model does, but it also concerns itself and describes and gives names to the input and output processes. So in my basic model of putting gasoline into a car, if we're using a black box model, it's just gasoline goes into a car. If we're using a full model, gasoline gets into a car because there's a pump that connects to an underground tank, and when that pump operates, it runs gasoline up through a hose and through a metal nozzle and into the gas tank. Do you see? We described the process and we named the process. We call it pumping gas, which is not included in our black box model. One more thing about models are controls. And controls are aspects or parts of a model or a system that affect how the system works. So temperature could be a good control on certain models. Some things happen faster when the temperature is warm. They'll still happen if the temperature is cold, they'll just happen slower. Say water evaporating. So in that case, temperature would be a control on a model that includes water evaporating. All right, and the last thing is most models, especially in science, most models end up containing some sort of feedback where one part of a system affects a second part of a system. A change in part A, we've talked about this in earlier videos, but a change in part A causes a change in part B. But then the change in part B also causes a change in part A. That's a feedback. And negative feedbacks, as we've said before, negative feedbacks push a system back towards some sort of equilibrium. Positive feedbacks keep changing in the same direction. All right. Moving on to our next video, we will briefly go over some other types of matter and other types of cycles in the Earth system. See you there.